Hello, everyone, and welcome to our webinar on AI, the good, the bad, and the ugly. This webinar will be led by Dr. Sam O'Neill. If you have any questions throughout the presentation, please drop them in the Q&A box and we'll run through them at the end. So let's get started. First, would you like to introduce yourself, Sam?
So my name is Dr. Sam O'Neill. So I'm a lecturer in mathematics and computing. I sort of specialise in mathematical modelling and in AI and data science. So are we getting started, Jess? Ready to roll?
Yep.
Okay.
Mm-hmm.
Yeah, so I mean, tonight's this evening's sort of talk is on AI, specifically some of the good parts, some of the bad parts, and some of the sort of ugly parts. We do have courses in AI and computing at the University of Derby, and I'll sort of talk about those a little bit towards the end. But this will be kind of sort of a whistle-stop tour of some stuff to do with AI. Hopefully, it'll sort of inspire you and sort of like help whet that sort of curiosity of mind, and maybe you'll find it interesting enough that you want to come and study that. So that's the main sort of aim in some respects. So firstly, what is AI and have I used it? So I'm going to give you an incredibly broad, simple definition. So artificial intelligence is when machines do tasks that normally need human-like intelligence. Okay. So things like understanding language, recognizing patterns, or making decisions. It's traditionally been very difficult for machines to understand language and recognize patterns. Traditionally, systems had to be coded to do specific things. AI in itself, you can sort of think it's not really magic. It's a lot of maths, huge amount of maths and data, and a lot of clever programming at the heart of it, really. And that's the kind of thing you would learn. I mean, you don't have to understand the maths to a huge extent to understand how it works, but it does involve those people that have developed these techniques, stuff that is heavily borrowed from mathematics. And just some simple things that you will have probably used today, whether you've used YouTube, Spotify, Instagram, TikTok, ChatGPT. These are all systems that have AI now built into them. Okay, so pretty much everybody is using AI on a daily basis. I'm going to sort of start with a brief history of AI, and just to give you sort of an idea of where AI has come from, and that it's effectively not a new thing, but we are in sort of a new era of artificial intelligence. So it's sort of born out of a summer project in 1956. So this is a very famous computer scientist named John McCarthy, and he was following up on work by Alan Turing and Alonzo Church. Alan Turing is famous for breaking the Enigma code during the Second World War, and is an absolute giant of mathematics and computing, and to some extent is sort of the father of computing, along with Alonzo Church. So this was a summer project in 56, and the idea was, can we create sort of machines that sort of think to some extent? We have the first Mark I perceptron. So most AI these days is built on what are called neural networks. Okay. And neural networks are a way of attempting to simulate the brain. And in fact, this work goes all the way back to sort of 1957, where somebody actually built a physical version of what we call a neuron. So a neuron is something in the brain, synapse in the brain, and there's lots of billions of them connected together. And they have electrical pulses that go through, and effectively they're responsible for your thought patterns and for your memory. So somebody built one tiny one of these, not the billion we need today. So this was actually a physical version of attempting to simulate the biological brain. We have our first chatbot in 1964, believe it or not. So we had Eliza, and Eliza was this psychotherapist, but she was hard-coded to sort of respond. Okay. So you ask a question and it would sort of, given what you'd asked, you would go down one path or another path, and then you would kind of respond from there. It wasn't particularly intelligent, but it was sort of the first way of attempting to, have something that interfaced like a human being. In the 70s, we have this sort of first sort of explosion, really, of AI, where it starts to look whether it's useful or not. And these are called expert systems. And expert systems are what we classify to be reasoning engines, and they're rule-based. So the idea here was to give a system a lot of knowledge, so lots of facts, and then somebody or a programmer would code in a bunch of rules that the engine would follow based on the question you asked it, and then it would feed back sort of knowledge. So this is one way of doing it. This didn't go very far, and the main reason for this is that most complex things like human language, like reasoning tasks, do not work like this, and we can't actually get particularly far doing this. But you can see this old computer. So these were in force for a long time. Another flashpoint was Deep Blue in 1996. I actually remember this. This is Garry Kasparov, who's a grandmaster of chess. And Deep Blue was a chess program that was designed, and it actually beat Kasparov in 1997. It lost originally to 1996, but was subsequently upgraded in 1997. And this involves specialized algorithms. So a lot of this was search techniques. So you can think of a chess game as when you are playing the game, there are a number of possibilities of moves that you could make at any given time. And given you make a particular move, there are then a number of moves that your opponent can make and subsequently you can make. And this sort of explodes. And we say this generally explodes exponentially, but there are more sort of solutions we can sort of deal with. So what you need is clever search techniques that sort of say, if I do this, what do we think the player will do next? And then we'll try and sort of map out what we think the best kind of pathway is. An interesting story about this particular one is in 1997 when Kasparov was was playing against Deep Blue, it came up with a move that he thought was unbelievably brilliant. He was stumped by this move and didn't understand what the computer had done, and he thought it had invented some kind of new way of seeing the game or whatever. It turned out that there was actually a flaw in the specialized search algorithm, and it got caught in a loop, and it didn't actually have a move to play. So the coders had written in a little break for that, which said, okay, just randomly move somewhere. So it spooked Kasparov, but actually what had happened is the system had just randomly played a move. But actually there's rumors that made Kasparov feel so weird about the sort of like ability of this AI program that it actually affected his performance in the latter games. 2002, we see the Roomba. This is a little floor vacuum cleaner that sort of like goes around automatically, hoovering up the dirt in your room and so forth. But again, these have been around since sort of 2002. So, this is 23 years ago, and this would be a version of an autonomous vehicle, which is classified in terms of AI. In 2011, we have Watson. Watson was a massive mainframe system that was built by IBM, and it was specialized in trying to play the game Watson. So Watson is just a general knowledge game, and it won, effectively it beat these two men here who were previous winners of Jeopardy, this big game in the United States. So this was again a big sign that we were already getting to a point. But again, Watson was very rule based. Watson had access to knowledge, but again, it was rule based, and by that I mean it was hard coded in how it went about the decisions. It could look stuff up and pull stuff back. 2012, we see sort of the first licensed autonomous vehicle. So this is a Toyota Prius that's been modified by Google, and actually this was awarded a Nevada state license. So this was allowed effectively to drive in Nevada. So this worked at the time by having a camera mounted, and then it would use the camera as a sensor to view the road, etc. And it had a model built in to sort of try and track the road and various other things. Autonomous vehicles have got much better since, but these, like I said, were deemed to be good enough to have a license back in 2012. So again, that's 13 years ago. AlexNet happens in 2012. So AlexNet is possibly one of the most famous things that in AI and as an academic paper. So there was a PhD student who, with a supervisor, used deep learning. So pretty much everything in AI these days is powered by deep learning. Deep learning is actually sort of the brain, trying to simulate the brain. So these here are all the little network neurons. We saw a slide earlier in 1956 where these neurons were hard coded. These are actually, simulated neurons on a computer, and these are then connected to every other neuron, and you can put some information in and you can get some information out. And these basically sort of try and simulate the brain. And actually, AlexNet, what they did is they cranked up the size of this network, and they actually managed to beat every known model that was doing computer vision. So by computer vision, I mean a computer's ability to look at something and classify what it is. So if I give you a picture of a cat, you'll most likely say it's a cat. If you give that picture to a bad model, it might say it's a dog. And there's an accuracy of how many things can you identify. And basically this smashed everything out of the park. And what this did is it showed all researchers and the world effectively that deep learning was the way to go. Fast forward 5 years to 2017, and Google released a paper on transformers, which is called Attention is All You Need. And what this did is it allowed us to train these big models here in parallel. So up to that point, when you trained a model, especially certain types of models, the ones that we were dealing with, trying to get them to understand natural language like English, you had to do it in serial. So what that meant is you had to wait for the next thing to effectively, for one thing to finish before you train the next thing, and so forth. And these models are so big that meant it took ages to do, and they could never scale these models big enough. What this paper did is it said, actually, there's a different way of doing this, and it allowed effectively these models to be trained parallel across hundreds, if not thousands, of different computers. Okay. And that meant it drastically reduced the training time, because if you've got what you would expect to be, 1,000 hours to train this particular network, if all of a sudden you can train those, you can break it into 1,000 pieces and train it on 1,000 machines, and they each take an hour, the whole thing only takes an hour. So you have made a reduction of effectively 1,000-fold. And this is kind of what's happened and allowed us to move to bigger and bigger and better things. So this led to the current explosion in AI. So these two things, and especially this one, are seminal in the world that we live in now. So most famously for people is OpenAI. So OpenAI are a family of what are called GPT models. In 2018, they had 117 million parameter model. So by parameter, I mean a single number like pi, 3.14 or 5.2, a single number. So there are 117 million numbers in this model. Okay, and those numbers are to do with that neural network. And what you can see here in this picture is that 2019 they've scaled to 1.5 billion parameters. And by 2020 they've scaled to 175 billion parameters, i.e. numbers. And now we're at a point where GPT-4 has 1.8 trillion parameters. Okay. So you can see that what's happened here is we've had this, since 2017, we've had this huge upscaling of the size of these models. And this is what's unleashed the sort of potential. GPT just means generative. So it generates new data. Pre-trained means that you just train the model, and then after you've trained it, you can just use it. So it costs a lot to make. It's cheap, much cheaper to use. And Transformer, well, you've seen Transformers with this technology. Okay, so GPT, generative pre-trained Transformer. Just as an aside for this, I love this stat. If you just take GPT-3, which is not the latest model, 175 billion parameters, it's trained on approximately 500 billion tokens. So a token is roughly a word. So as I say this sentence, it's effectively 5 words, right? So it'll be 5 tokens. So it's basically, they scoured the web and they scoured various things for data, and then they've just trained it on this. And it's estimated to cost $4.6 million and a total of 355 years to train. I think this is the important point. It clearly didn't take 355 years to train, given that they started training it in 2017. This is what parallel computing and the Transformer allowed us to do. it allowed us to scale to this sort of crazy amount of training. Okay. I think we need to mention the launch of ChatGPT. I think will be a seminal moment in human history. On November 30th, 2022, ChatGPT was released, and this has sort of launched an explosion into what are called large language models. So these are things like the GPTs. So they're things that attempt to understand natural language and talk back to you. Large language and a model. So it's a very big language model. All right. So I just want to briefly, before I move on to sort of the good parts, the bad parts, and the sort of worrying parts, just to speak about computing and AI. So AI itself, in terms of actually the build that you require, it requires all these sorts of things. It requires high performance computing. Okay, so we need we need parallel processors. We need graphics cards that are and TPUs and all these various things. And not only that, we also need very clever algorithms that run on these. And if you can get the two right, you can very quickly speed up your training. And we've already seen that speeding up training leads to bigger models. Bigger models leads to better AI. We require lots of understanding about machine learning statistics, lots of data engineering, parallel distributed computing, again, for the training, lots of software engineering. There's huge amounts of concerns around cyber security and privacy, ethics. Embedded systems and edge computing is one. How do we get AI to run on small devices that we employ in the field? For example, you can put stuff out in the African savannah sort of desert, and it could be monitoring things, and it could be doing clever things without the need for a big computer. Graphics and simulation, we train a lot of interesting things using graphics and simulation. A lot of robots now are being trained in virtual environments. So we build simulations, graphical simulations, and NVIDIA are very big on this. And then we put a robot's brain in there for it to learn. And then you take the robot brain, you put it back in the robot, and you have it navigate the real world, right? So the simulation. So plenty for you to get your teeth into if you're interested in AI. Okay. So the good, the bad, and the ugly. So again, I won't spend too long on each of these, but I just want to give you a overview of where AI is sort of touching our lives, some of the good parts, the bad parts, and as I said, some of the ugly parts. Okay, so you're learning your way. I'm quite big on this. I'm a big proponent of using AI in the classroom and for education. I believe AI has the power to sort of revolutionize education. And I think it should be something that is used by students and by staff to improve everybody's experience. Okay, and here's an example of a student who had dyslexia, and again, AI has helped improve her reading. Right, so it's a fairly obvious one. Dr. AI will see you now. So we are already seeing a huge amount of AI in healthcare. And in fact, the government put out a huge amount of money for the use of AI in both education, but also in healthcare. So again, AI doesn't get tired, and it will catch things that humans miss. Because the pattern recognition is so good now, it can do things that we actually can't do as human beings. It's got to that point where in specific tasks, it surpasses the ability of the best human. An interesting story is an AI researcher built a system to sort of scan for lung cancer, and it turned out that it found that his wife had lung cancer and saved his wife's life, which, it's very serendipitous, but remarkable story. But you get the point. You can build these systems. Let the bots do the boring stuff. So better jobs, not fewer jobs. I think there's a thing here where everybody's going, yeah, oh my God, AI, what's going to happen to the job market? Is it going to take all our jobs? And I think there's a great worry here. This is the Future Jobs Report. And it shows that at the moment, the total job growth is above the loss, right? So when you take the net between them, there's actually job creation. So what's happened is maybe 92 million jobs are displaced. That does mean people will lose jobs, but it means that 170 million jobs are created and other people will get jobs. This is normal in a job market. Jobs disappear all the time. New jobs are made. It's unfortunate for the people that lose their jobs, but it is just a normal, it's happened throughout human history and will continue to happen. But again, you can see this means that. And I also want to point out in this particular webinar, given that we're doing a sort of computing AI one, that actually, if you take a look at the fastest growing and declining jobs by 2030, the top 9, so if we look at the first 9 of these top fastest growing jobs, 9 of the top 10 are based around computing and AI. We have big data specialists, fintech engineers, AI machine learning, data work, and so forth, right? And in fact, a lot of the ones afterwards, again, are AI. So I won't necessarily read the declining jobs, but these are things where there a lot of data entry, which we expect AI to be able to do to some extent. And also, if you look at the industry-ready skills, so the top 10 fastest growing skills by 2030, I think it's really, really fascinating. If you look at the first 3, it's AI and big data, networks and cybersecurity, and technological literacy. And then interestingly, the next sort of 4, creative thinking, resilience, flexibility, agility, curiosity, lifelong learning, and leadership and social influence, are things that you get from studying a higher level degree. So if you come to a university, it's expected that you will improve your critical thinking, your creative thinking, your analytical thinking, your leadership, your curiosity. So it's not just about learning some stuff about AI or computing, it's these other skills. So I think this is really positive, because what it actually shows is if you came and did a degree in this area, by 2030, actually the market's grown for this. For some, AI isn't just smart, it's independence. So this little robot here is Jenny, and she's a socially assisted robot who's designed to provide companionship and stimulate oxytocin release. So my gran suffered with dementia before she passed away, and it's a terrible, terrible disease for the person, but mainly for the family members that see the degradation in their loved ones. And again, this shows a way where we can actually try and give those people a better life. AI can see patterns across the planet. So it's currently being used in Africa to detect poachers. So they have these drones that fly above the above the national park, and they scan for the poachers. So they're actually using computer vision and machine learning models to find poachers, and then they can relay that back, and somebody can come out and stop those poachers. So this is helping save wildlife. Scarcity to abundance. So AI is also helping farmers. So what you can think about is, if you've got crops, if you can somehow have models that can predict whether plants are susceptible to crop disease or whether a crop disease is starting, you can get in there earlier and stop it spreading to the rest of your plants or crops. You can obviously think about yields. What's the best way to plant these? And you can do all this sorts of stuff. And there's in fact autonomous tractors as well. So self-driving tractors, which means that we can have more tractors out there producing more stuff. So again, AI can help produce more, which obviously helps the entire planet. Okay, the bad then. Privacy, big problem. So Big Brother is sort of George Orwell's dystopian novel, to 1984. And in 1984, there is sort of this notion that everything you do is sort of monitored. And, you know, I'll give you many examples of privacy issues, but one in particular I'd like to highlight is in China, they were trialing headbands that monitor your concentration. So they're actually putting these on school children. And the notion is, you know, that their concentration is being monitored, which I find, well, I won't comment on that particularly, but you know, you can see for me, that's not a good thing. And, you know, but that's using AI in not a particularly good way. And, you know, in terms of privacy, we are overstepping the mark a lot of the time. People are overstepping the mark in terms of the data that they mine on Facebook, on TikTok and so forth. And if you submit your data and so forth, and, you know, if you're not sure about how your privacy works, then you can be targeted for certain things, adverts and so forth. So it is important to consider. Bias in, not so neutral. So a model is only as good as the data that goes in. So if the data that goes in has inherent bias in it, the model that you build will have bias. So in 2018, Amazon's hiring AI, which they built, started to prefer men. Why? Because Amazon had a bias in their data set where they'd preferred men. In 2019, a US healthcare AI system favored white patients over black. And and both of these are copying the bias of human decisions. So your data, your model or your AI is only as good as the data, at least at the moment. So what you want to do is you need to be careful with the data that goes in. You can't just throw data at it and expect it to work the way you want it to work. But interestingly, you can flip this question on its head. It can show you issues in your original system. So actually what this highlighted is that we're already biasing the Amazon hiring system and the US healthcare system. Robots took my job. So again, I did allude to, I think it's very good that we have this sort of growth in computing, but you could see obviously people are going to be displaced in their jobs. So in 2023 in June, IKEA started to replace their sort of central roles, call center roles, with an AI bot. But what I like about the IKEA story is that they didn't lay the staff off. They just retrained them and put them into a different place. So they moved them. So they rehoused those people. So they were displaced, but displaced within the company, which means they didn't lose their job. And I do like that. But it is clearly an issue. And I'm not going to just stand here and say, or sit here and say, AI won't take your job, because for some people it will. There's also a saying that is bandied around quite a bit now, which is AI won't necessarily take your job, but somebody that understands how to use AI will probably take your job. It will become more and more needed as a work skill. Deepfakes. AI can now fake your voice and your face in reality, and we see this regularly. We've seen numerous disinformation campaigns from Russia recently. Iran did one the other week, etc., where they're releasing things, deepfake videos about stuff. And again, an example is the Ukrainian president Volodymyr Zelensky was circulated online claiming that or calling for the Ukrainian troops to surrender, which was not true. And you can see how this could be used in warfare for means that are more nefarious. It is something you should be aware of. I mean, and it is something that the AI community is looking at how you police it, but it is difficult. Okay, and you should always be aware of your sort of cyber security and how you deal with phone calls that you get potentially, text messages you get. You need to make sure they're through official channels. And finally, just onto the dark side before we wrap up. And this is true. I've mentioned a bit before. We are building technology, that makes life or death calls, and technology that does result in human casualty. The 2023 conflict in Gaza, which is, effectively still going on, Israel used an AI system called the Gospel to identify and prioritize targets. There's plenty of AI in US, Russian, UK, European military. And actually, you can imagine that we move into a point where there will be a lot of autonomous warfare. And unfortunately, as we're seeing at the moment, warfare at the moment is a part of the global community. So, again, not a great thing. But you can flip it on its head and say, well, at least those soldiers are not necessarily being killed. But again, I'm not going to comment particularly on this any more than that. Skynet. So, if you don't know what Skynet is from the Terminator movies, which is an AI that becomes sentient and then effectively decides to launch all the nuclear weapons in the world and effectively, obliterates most of humanity. And it's a common dystopian story that AI will go to a point where what happens when it becomes sentient, and what happens if it thinks, human beings are responsible for this and so forth. I give you lots of stories about that. There's a very famous game called Paperclip. I urge you to play it. Just Google the Paperclip game. And the idea of the Paperclip game is to make as many paperclips as you can. But actually what happens is, as you get more and more money, you can buy bigger and bigger tech. Eventually you get to the point where the AI, you build AI and the AI is building you paperclips. But it becomes a point where you run out of metal. So what happens? And then the AI starts to go after cars and various other things. You can think all the AI is trying to do is optimize for profit of paperclips. So it doesn't really care. It doesn't think about anything other than it starts to try and take these cars and other bits of metal and just make more paper clips. And that's the simple version of where the AIs are not aligned with human sort of perspectives and what we would like. And that's actually known as the alignment problem. Okay. Now, I would say the good thing is, whilst experts are a bit nervous, I still think most people are on the side of it. It's not likely to happen, especially with this round of models that we've got. They appear to be very good at certain things, but they are by no means sentient. And you know, there are whole rafts of researchers working on AI safety. And my personal take is, I wouldn't attempt to try and build something that became sentient. I became understood its place in the world, i.e. truly intelligent, as we might call it. I would just try and build systems that help humanity for the better. And just a couple of slides to the end, right? So just to give a bit of a positive from this, the future is unwritten. So this is a quote by Joe Strummer from The Clash, so band from the 70s, a sort of punk rock band. I think it's quite poignant. The future is unwritten, and it's only written, and it only becomes written when it happens. Therefore, you can always shape the future. AI research can shape the future. Politicians can shape the future. Anybody that is in a political system can shape the future. And I think it's important to state that. There is a AI for Good Global Summit. So just to give you a positive example again, this is a summit that is looking at how do we, make AI to try and move towards a more utopian world rather than a dystopian world. Okay. And again, I would say this is a nice quote. AI is not the destiny, right? This notion of, oh, well, it's just going to become sentient and so forth. It's not. It's design. It's our choice as humanity to how we move forward. And I do think we're at an incredibly interesting time in humanity, and it will be our choices over the next 10, 15, 20 years will shape the future, the short-term future and the long-term future. So just to sort of leave with a slide here, which is, or before questions, AI is going to shape the future, but if you get into this world and you're interested in computing and AI, you can help shape that future. It's your future. It can be your AI. And I would encourage you, and I would encourage anybody that's interested, to be curious about this subject and be critical about it, and to most of all try and be human about it and understand where it can benefit us, and understand that really, to me, and that's my opinion, but this is how we should be looking to use it. So that's sort of wrapped up. And like I said, it was quite a whistle-stop tour. I understand a relatively lot in that, but I just wanted to give you a flavour of things. Just to mention, we do have a number of courses at University of Derby on these areas. So of computer science, computer games programming, computer games modelling, animation, Internet of Things, information tech, cybersecurity, and we have artificial intelligence and data science. And I think I'm going to hand back over to Jess if there are any questions or whether how we want to proceed, really.
Hi, Sam. Thanks for that great informative presentation. We just had a couple of questions through this evening so far, but as Sam said, if you do think of any after this webinar, please do drop him an email and he'll reply to you. So the first one tonight is, what facilities will I get to use as a student here at Derby?
So let me just jump my PowerPoint. We've got a number of facilities. I mean, we've obviously got the standard facilities on sort of campus in terms of your amenities with the gym and so forth and other bits and bobs. But in terms of specialist facilities in the computing department, there are specialist computing labs which have a range of software in. So it's not a requirement that you need your own machine. You can do everything you need within the labs. We have a dedicated XR lab. So XR is effectively extended reality. So like virtual reality, for example, or augmented reality. So you'll see people with these big sort of headsets on and so forth under VR. So we have an entire lab dedicated to that, and specialists that help students build virtual reality stuff. And I think augmented reality and virtual reality will be quite a big thing in the future. And we also have a makerspace where you can use things like laser printers and various other things, and you can actually engineer stuff. So if you're more on that sort of embedded computing side, you can also do those sorts of things. So in terms of specialist stuff, and that's what we offer. And then obviously there's the standard sort of campus things, which, I mean, again, I would employ you, if you're interested, to come on to campus, and you'd get a chance to see those during an open day.
Super, thanks, Sam. Someone has just asked what percentage of the course is AI, so I've just asked them what courses that they're interested in. So we'll just leave that one for a moment and hopefully reply. And the other question I've got here is there an option to do a placement year on your computing courses?
Yeah, so we between the years 2 and 3, so your second year and your third year, you can do an industrial placement. You don't have to decide that until you're in the second year. So you come into a normal degree, which is 3 years long. And then if you decide to get a placement, what we do is we help work with you to try and get a placement. You can attempt to do that yourself and get a placement with somewhere where you'd like to go, but there are also options that you can do through the careers sort of department. We actually have a student this year who last year was on a placement with Arm. Arm make the chips that are in effectively almost pretty much every single mobile phone. So all your mobile phones and so forth, they run a chip that's very energy efficient, and it's from a company called Arm. So Matthew, he was at Arm last year, and then he was pretty much offered a job as soon as he finished his placement. And he's actually he's completed his degree, so came back to do a year now. And he is now off to do Arm, and he will be on a salary that is probably a lot larger than mine. So, there are plenty of opportunities to do that, and it can lead to some absolutely sort of world-class roles. And Arm are a world-class, a blue-chip company, probably one of the most important companies in the UK, and that's a student of ours that's gone there.
Great, thank you. So you've had a comment or a reply back saying it's the AI and coding, they think. So I think it must be the AI and data science, but maybe you could cover quickly the if there's any AI and computing science, I know you cover coding in that. So the question really was, what percentage of the course is AI? Yeah.
So, I mean, it depends. It depends on where your interest lies. The AI and data science is more about AI and how you build and model AI and you use it to solve problems. Now, a lot of that is actually, in terms of the way we deal with it, is actually your ability to take a problem, understand how to structure the problem, and then understanding what type of techniques you need to apply, building the models, testing that the models work, and then deploying them in the real world. If you're more interested in you will learn about how AI works, but if you're more interested in coding and building software and understanding that sort of cycle, software cycle, computer science is a really good option. You will learn about AI. And in fact, I have supervised 7 undergrads. So when I say supervised, you have to do a sort of a final project in your third year. And all 7 were doing AI, but all 7 are from computer science. So it's not necessarily that if you pick computer science, you're not doing AI. It's just computer science is a much broader area. But obviously, AI is the dominant thing here. So you will be learning about how to do a lot of this stuff, and there are options on that degree for you to do that.
Perfect. Thanks, Sam. It looks like you've answered all of the questions that we've been asked tonight. So I'll hand back over you just to kind of wrap up the webinar. That's okay.
Yeah, sure. It's nice to deliver this. I think my parting sort of thing to you would be, if you are interested in anything I've talked about, then please, either email us or come to one of the open days and speak to academics. As I said, it is something really interesting that has a big payoff in terms of your potential career as well. But as I said, it's fascinating, and I think you'd sort of really enjoy studying a degree here on whether it be a computer science, artificial intelligence, information technology. So if you do, please pop and say hello, and I will say hello back. So thank you.